live, aren't you?
Who's live though?
Tyler is.
No, you are.
No, I.
Welcome to Filament Live. Yeah, it's really hot in there. Today we're talking about failed 3D prints and the consideration into making filaments for 3D printing and how to solve prints so you don't have bins like this. Started. Baby. That's a lot. Be really quiet.
You got it. There you go. And here's Kevin. All right, well, we're gonna just kind of go over some of the common failures and talk about how that relates to the properties of some of the polymers that you're going to use in your 3D printer, or some of the ones you're going to experiment with, because we do a lot of experimenting, so we have to find solutions to a lot of these issues. So one of the main one is your print comes off of the bed and like completely disconnects, can't continue anymore, or your printer skips, because most printers use stepper motors to control their axes, and a lot of them don't have feedback. So if you get one that skips, it doesn't know it and it just prints off to the side, and we'll show some examples of that in a second here. Or your extrusion stops. So we're going to talk about how that might happen and what you can do to prevent it. So let's talk about a couple of these examples here. And then we're going to also talk about some more specific issues relating to like your printer type and issues with extruding, obviously, because we're Filament and we do extruding sometimes. So the first issue I talked about was your print coming off the bed. This was an example that eventually did that, but a couple of causes are your nozzle catches on the edge from warping, or it warps off the bed. So here's an example of a print that warped off the bed, and this is because polymers have a pretty high thermal expansion, and so when they cool, because they're hot when they get extruded out of the nozzle, they shrink a lot. And if you don't have a good adhesion to your bed, and sometimes you can't prevent it because polymers have a really high shrinkage that can't be prevented, you'll get it peeling up from the bed, and it will just fall off. Another very common issue is edge warping. So what you'll have happen is, especially on overhangs, if you don't have a lot of support material, this is like a big square frame print. This is support material, and sometimes, and it looks like it happened around the support material, but it's the same issue where the polymer shrinks, and what happens is the edge of the part curls up somewhere, and this happens especially on overhangs, and the nozzle will catch on the print and either knock it off the bed.
Kind of like this here, right?
Yeah, but that was because it skipped. So it'll either knock it off the bed, or it will catch and skip. And what happened here was it caught, and one of the axes skipped, and it started printing off to the side, and that happened actually a couple of times.
Yeah, you can see probably 3, 1, 2, 3, 4.
But those two issues are mainly caused by the polymer shrinking and the nozzle catching on the edge of the print. The other thing that happens is your extrusion will completely stop. So there's a lot of causes for that.
And the extrusion is, the hot end of a 3D printer, and then the extruder here. So this is when the filament's getting fed in, and it'll either stop, and there's a bunch of issues that we'll touch on right now.
So one of the issues is diameter variance. There's also low temps, and I didn't write them all down actually.
Well, there's low temperatures, there's melt flow. Do you want to go through them all and then touch back on them? Yeah, let's go through all of them.
Okay. So I guess one of the first issues that I actually forgot to write down is if you have some debris in your filament. So debris could be either contaminants like dust and dirt, or even a different type of polymer.
Right, if you have filled polymers, like a carbon fiber or wood-filled material, and your nozzle size is too small, those fibers inside the plastic will build up and jam your nozzle.
Yep, and you can also have contaminants like stuff
dirt
that you don't want in there, like
Right.
other types of polymer and dirt.
And that's a big consideration for us when we're making filament. So we have a melt filter in our system that captures all those particles as the system.
Oh yeah, I wanted to get a melt filter and talk about it at some point.
I saw Josh's head pop up when you said that.
So
yeah, debris. We have a filter system on the Filabot, but if you are printing with materials with filled or dirt or dirtier materials, sometimes a manufacturer of filament, something you'd buy elsewhere, may not have a melt filter while they're producing filament, and that could cause your extruder to stop and plug, and then you have to take the nozzle off and clean that out and get that all cleaned up.
also, if you're mixing in colorants, sometimes you can get, if your temperatures aren't right, your colorant doesn't mix very well, and you can have like clumps of colorant that's not melted all the way. If it's the wrong colorant for the type of polymer you're extruding, that can clog your nozzle too. So the drive system on most 3D printers is a little kind of gear piece, and that's tensioned on the little bearing tensions the filament on that, and that gives the pressure that pushes your filament down through your hot end. It's exactly like a little hot glue gun basically. So if your nozzle clogs, your filament just won't push down. It'll actually wear through it and cut it off. But we can talk about the melt filter after.
Okay.
But
thanks for bringing it over.
Yeah. So another issue is temperature, and that kind of ties into warping and stuff too. So if your temperature is really high on your print, that's going to cause more thermal expansion, which in turn is going to cause more shrinking, and that's going to cause your part to warp more. So you want to extrude at just at the melting temperature of the polymer, so that you're not going to cause too much warping.
And that's,
where are they going to go with that?
I mean, for materials you buy offline or other manufacturers of filaments, they'll have the temperatures worked out. In our case, when we're playing with different polymers, we have to you have to test the different ranges of hot end temperatures and build temperatures, or build plate temperatures, to find that good temperature to where the filament isn't going to slip, where the drive system can't push it.
The drive system isn't going to push it anymore.
Melt flow, so that kind of ties into the temperatures.
Yeah, so if your temperature is too low, your melt flow will be too low, which means the polymer it's thicker. So if the melt flow is low, that means the polymer is thicker when it's melted. And that's going to limit how fast you can push it through the extruder. And if your temperature is too low, it's going to make the melt flow lower.
Right. Which will then make the extruder slip, and then that was one point. Where was that one? Oh, that's your last point there. Actually, let's dive into that. So if your nozzle's jammed, if you have melt flow or low temperature, what's going to happen is that this drive wheel, this tooth gear on the extruder here, is going to grab and start just chewing away at the filament, right? And it'll basically eat it away. We've had times where it eats it fully, and it breaks off and it can't continue to push. So that's a big issue there that you want to solve. And then the next one was soft filament. So
different extruders can be designed for softer polymers, where it will bunch up right below that little gear tooth or little drive gear that pushes it down. If it's too soft and it requires a lot of pressure to push through the nozzle, it'll bunch up right there.
Right, and
those just clog.
Those materials are like Ninja Flex, TPU, Filaflex. What are some other ones we've worked with?
Even ones that are slightly stiffer, like LDPE and HDPE, will still bunch up a little bit.
Basically, if it's a flexible material, it can have that bunching effect. Yeah, so that's some issues with the extruder, this piece here on the printer. We've done edge warping, coming off the bed. Do you want to dive into the diameter variance? Because that's a big one.
Yeah, let's see, can we relate any of these other... So the main point of this video was to talk about how the properties of polymers relate to printer issues. And we went over the warping. And that type of information can be found on the data sheets for the polymers. So if you have a polymer, like one of the ones that we've had a lot of trouble with is LDPE and HDPE. They have a very, very high shrinkage. They're very difficult to print with because at their melt temp, they expand a lot. And once they cool, they shrink and warp a lot. So they polymers that are designed for 3D printing like PLA are designed so that they have a very low shrinkage. So that's like the number one thing I would say when you're looking at a polymer to print with is that it has a low shrinkage. And we should have got some numbers.
We could throw those up later. Bummer.
We have the data sheet. Can you get me the data sheet for PLA?
3850, 70. Thanks, Josh.
'Cause that would be cool to like look at the properties of the polymers and kind of talk about them.
Yeah. One thing I don't think we've touched on is, well, can I dive into the printer
let's
themselves?
talk about like bed adhesion.
Yeah. So some solutions. I mean, we've talked about a lot of variables and issues. The points that Kevin have are like the main core issues to why a print fails. We've worked with a lot of printers. We worked with a lot of customers who have different 3D printers, and we just want to quickly go over some specifications or things we like using while we're 3D printing to solve those issues. The issues of the print coming off, the printer skipping because the print is warping, and extrusion issues. So those are the three main, and here are some things that we use to solve that. The first one that I use is I use the MakerBot sometimes to print, and what I'll do is I have these cardboard sides. Let me go grab those. So I'm not sure why MakerBot doesn't have this already. This is a sweet upgrade. Basically, I take cardboard sheets and I'll put it around the printer and I just tape it on. And what that does is builds a enclosed area where there's no drafts coming and cooling the print.
Yeah, you're controlling the environment.
Right. And the MakerBot does not have a heated bed, which is kind of a downfall because having a heated bed allows for warping not to happen. So I will tape it up like this, and then I can run a successful print. I'm sure they're gonna love this video when they see it.
Because you don't have a draft.
So there's no draft, right?
That's one of the other things is bed heat and cooling. That's kind of a way of controlling the environment around your print. So if you can reduce the temperature difference between the melt temp of the polymer and the solid state of the polymer, where it's basically solid, you can keep it from shrinking so much. So if you have the part all at one high temperature while you're printing, and then you cool it all at once, then the print will be successful because you won't have it warping as it's printing.
And cooling.
So in most open air printers, it's cooling down to room temperature as it's printing. So that's a high temperature differential, which makes for the worst warping.
Right.
But if your printer has a heated bed, that can help keep the environment and the first layer, which is the most important for adhesion.
And a heated bed is this actually gets hot. So you can program this in the slicing program to bring this to an elevated temperature. What do we print? Like PLA, we don't really use. ABS and the more interesting grades of polymers will bring that temperature up. I think that 110C is kind of our upper limits that we use. But yeah, that's the heated bed part, and then an enclosure part. Big consideration there. And then the next thing is, you can see how there's two different materials on this printer bed. We have this tape, which is called Kapton tape. It's a tape that's actually used in electronics to hold down wires inside of cases and TVs.
It's a high temperature
Yes.
tape. Yeah,
and what Kevin, what you do is you use the Kapton tape with a very thin layer of Elmer's glue, like the stick, right?
Yep, for ABS
Okay.
specifically.
Would you use that for PLA?
I do not. I use the plain, because PLA actually, another property that isn't really on the data sheet, but that's very helpful, is PLA, when it's melted, has a very high,
Stickiness?
well, the melt flow is high.
Okay.
So you can work with when it's melted, the surface tension of the polymer actually holds it down on a smooth surface really well.
Jesus.
And then when it cools, it stays there because it's in that shape.
Right.
So if you're printing with PLA, a really great surface for that is
Just straight
this
Kapton.
build tack actually works on that same principle, but a smooth surface works really well for PLA because of that surface tension. When it's melted, really holds it down to a smooth surface.
Nice.
But
So we have Kapton tape, glues, there's hairspray. Some people spray hairspray. That can get a little dangerous.
there's all sorts of wacky solutions
yeah.
out there.
We work with a wax material. We've turned a wax into filament, and Kevin came up with gluing a sheet of paper down and then printing directly on top of that sheet of paper. I don't remember what type of paper.
It's just any type of paper, because wax is a lot more viscous when it's melted, so it can soak into
Dunder
paper.
Mifflin sheet, right?
Something like that.
Huh? Okay. So, the other one's build tack. Build tack is similar to this. It's basically a plastic that grabs on to the melted polymer. And I think, who else? Wait, you print with the build tack? Yep, I love build tack. It works really well for a range of materials. But yeah, there's multiple options for bed, and that is all to keep your part anchored to the machine as it's moving. And then we have enclosed build area versus an open area, limiting the drafts around the print as it's cooling that Kevin touched on. And then
Building on that, we should talk about cooling. So if you're trying to prevent warping, one of the solutions is to cool it more quickly, right where you're printing, so
as you're printing, let's actually, does the MakerBot have? Ooh. So this is a little dirty because, well, we print with it. But this is a fan duct right here where air is blown in and then it's directed towards the top of the print. So it's laying it down and cooling it as soon as it's being printed. In slicer programs, you can turn that on and off, and then you can set the fan to different speeds depending on how quickly or, depending on how quick you need to cool.
And the reason for that is we just talked about how the whole part, like the high temperature difference, causes issues. But another issue is actually if you're printing, especially with small parts. Here's an example. If I can focus on it, if the layers, this is difficult because it's like a white part.
Not showing up too well.
There we go. So there we go. So on that corner there, you can see the layers are kind of all warped up. That might eventually cause a print failure. But the reason for that is the layers underneath the layers you were building on were almost still melted. They were so hot. So you don't want to cool your part too much from the temperature of the nozzle, but you also don't want to cool it too little, because then it'll stay melted and cause more warpage right here.
That dang warpage.
Yeah, so that's one of the biggest issues with 3D printing with polymers, is just dealing with that number one property, which is the high thermal expansion.
Right. And versus injection molding, when you're just throwing a bunch of plastic into a mold, they do have shrinkage, but it's all controlled
It's all at once, yeah.
Right. But I mean, this print, I mean, any 3D print has thousands of different layers that are all cooling at different rates. So I think having a enclosed printer can really help.
That helps. Like, so some of the multi-$1,000 printers use completely controlled environments. Stratasys for years has used ABS, and they don't have warpage problems because they heat the entire build area to just below the
all
yeah,
around.
or all around the printer to just below the melting point of the polymer.
Yeah.
They also have fans on their hot end, so they don't want it to stay melted too quickly.
Yeah, so the printer bot has a fan here, which is blowing air, you know, sucking in here, and then blowing it towards the print. That stops extrusion, which is something we wrote that down. If you cool the hot end too much, I mean, obviously it's not going to be hot enough to push that filament through. So that fan cools the print down and sometimes can cool your nozzle. So that's something to look out for. There's a bunch of 3D, if you have a printer bot, there's a bunch of 3D printed ducts you can get to work with that. And I think that also ties in with speed of printing, right? So you kind of touched on this. When you're printing this and going really fast and it's not cooling and the layers are kind of warping up, having that fan will allow you to print faster as you're building an object. What else do we have? It was cooling, we had bed temperatures, filaments. Yeah, I guess we'll dive into filament tolerance, right?
Yeah, we might as well. So,
do you want me to film you on this? Because you have a great explanation to it.
Sure.
Da da da.
You can just go at the same distance that
You look
actually
great.
here. Just half touch the button.
Half my finger or halfway down?
Half click. There you go.
How's that?
Do it again. Alright, that's good enough.
Nice.
Alright, so where's my example print?
Ooh, this is kind of
So
fun.
when you have
Can you like not move this quick though?
oh, there it is. So when you have
Okay.
can you yeah, that looks fine.
That looks good.
So filament diameter tolerance is the main issue that we focus on with Filabots, on top of melt filters and just the general properties of the polymer, like the softness and how easy it is to extrude. But diameter tolerance is the main one. And a very obvious problem you might have is if your filament's too big to actually fit inside your
Don't look at the screen. I'm not focusing that well. Oh, I just had it. Okay, well that shot's over with anyway, and we're back.
Okay, so if your filament gets too big to even fit in your extruder, it's going to stop. But the other issue is if it gets too thin, it could break.
I'm gonna go and then.
And the other issue is if it's changing, you're going to have variation in the output of your extruder. So most extruders, the desktop versions, don't have feedback for the diameter of the filament that's going into the printer. So having a very tight tolerance on your filament is important, because the way these extruders work with the gear that pushes the filament down, it goes at a constant rate because it assumes the filament's in a constant diameter, which means it's a constant volume going through the extruder. And if that volume is changing, what's going to happen is you'll have less volume coming out at certain points. And if you can see the striations here, you might have to get a little bit further away.
I think I can.
You can see this one really clearly, where there just wasn't enough plastic coming out of the nozzle because the diameter got too small. But so that's the main issue we focus on.
Right. So when we make filament, we're always shooting for the plus or minus 0.05 millimeter tolerance for filament.
And for most layer heights, that's pretty acceptable quality if it's plus or minus 0.05. What is that? That's
it's tiny.
That's less than, for 1.75 millimeter filament, that's less than 1%. No, it's around the 2%. So that's a 2% variance in the volume that's coming out of your
Don't worry, it's live.
extruder. Yeah.
Nice. All right, I'm giving it back to you because I don't know.
Well, I just wanted to talk quickly about
Oh, the melt filter?
some of the polymer properties.
Oh yes. So this is 3870. This is the newest PLA that is on the market.
So let's see, we can see specific gravity, which is what we call the melt flow. And then also, do they even have the shrinkage on here? They might not have the shrinkage on here because generally that's for mold grade plastics, not extrusion grade, because usually in parts that you're extruding, you're going to compensate for the shrinkage anyway in your part design. Or for extrusion parts, you're going to compensate in your extruded. But for injection molded parts, you need to compensate for the shrinkage in the part design because you're making a $10,000 mold that you want to work the first time. So for extrusion grade polymers, they don't always put the shrinkage on there. So I can't show the property I wanted to show, but
Well,
anyway.
it does have that property, we promise. It's just not here.
It's just much lower than like
Right.
ABS or a lot of other polymers.
In general, a material, I think it's safe to say that a material that has low shrinkage prints very well. Granted, you can get into filament form and then get the tolerance
Yeah,
you
there's
need.
other properties you want too, which is like
Right.
strength and stuff like that.
Earlier in the video, do you want to go to the melt filter now?
Yeah, we could talk about it quickly and get a
One of,
video on it.
yeah, it's getting kind of long.
Well, it doesn't
Okay.
matter how long it is, but
All right. So earlier we talked about how your 3D printer can clog the nozzle, right? And as you print finer and finer, that small hole, I mean, the printing nozzle size is like 0.4. That's the average. But you can
0.4
go,
millimeters.
yeah, 0.4 millimeters. And you can go even smaller than that. So I think the smallest I've seen is like a 0.1, which is tiny, very tiny. So you can imagine if you have any speck of dirt or anything, dust from extruding, something that got in the hopper of either our machines or your other manufacturers' machines. Whoa, I almost slipped there. You want to make sure that it's clean, otherwise it's going to clog. Then you have failed print, and then you got that whole problem where you're climbing out of a failed print bin. So for Filament systems, what we do is we have a nozzle which is custom made, which has a series of screens, and this is the screen that captures all the contaminants that is not plastic, that's not that grade of plastic, while it's extruding. So I think this is a number 20 mesh, and basically that's the...
No, this is the 20 mesh. So
Oh, this is the...
with mesh sizes, yeah, we
Goes
have
the
the
other
mesh
way.
sizes on the website. With mesh sizes, the larger the number, the larger the mesh. Is this the 80 or the 60, Josh? 80. 80 mesh, and then this is a 20 mesh, which is a support mesh.
Right, so I can put this together to show you kind of how it works, but this is just a nozzle to our EX6 system. We have the same melt filter nozzle, not the same nozzle, but the same setup for the EX2 and the Filament original. First we put the backer plate in. This supports all the pressures that are coming from the plastic. Don't look. There we go. That goes in. We put our supporting mesh, which is the 20. That goes in. And then we put this is the final, what is this? This is the first mesh that hits the plastic, but you can change this, and if you go larger, it's going to increase your size, but it's not going to capture the finer pieces that could potentially jam the printer.
Typically you want to use a size that's maybe twice, so the opening size in the mesh should be like twice the size of your, or should be 2 times smaller than the size of your nozzle. It's typically a good rule to go by.
So there is an assembled melt filter for the EX6. This will screw in and replace your standard taper nozzle on our extruder system, and that'll capture the material, the contaminants in the filament. So
Yeah,
this is...
and it'll also stop like polymer that has a higher melt temp.
Right.
It'll sit there on the filter, and sometimes it'll even melt.
Right, and that was a big, like a lot of people have raised concern, like what if my polymer's dirty? You want to have your failed prints like this somewhat clean. You don't want to have dirt on them or tape. You want to make sure that's removed as much as possible. But with a melt filter system like we just showed you, that's going to make sure that nothing gets into the filament. So you don't have any bad printing.
Yep.
Cool. Should I climb back into the bin? I really don't want to.
I think we covered everything. It was a little bit, it wasn't as streamlined as we were hoping for, but we got some points out there.
We could always do another one.
Yep.
So until next time, thank you for watching. We enjoyed making this video. I hope the rest of the team did as well.
Nope.
Yeah. I thought we weren't supposed to do that anymore.
Yeah, quiet on the set, please.
If you have any questions about printing or filament extrusion in general, please give us a call or shoot us an email. We're always happy to help. Thanks.
Go team.
What are you doing on your phone?